Writing ionic equations. We're going to be looking at writing two types of ionic equations and really one's for the first step of the other one. So the first step is what's called a total ionic equation. Essentially what you're going to be doing is you're going to take a chemical reaction and you're going to be writing it out as the ionic substances actually are. So what that means is, though we may write sodium chloride as NaCl, being as it's an ionic compound, we know there's a lot more to the story than just a sodium and a chloride, especially when these guys are aqueous and they're in water. So a total ionic equation will show that understanding, that we know what these guys are actually like as a particle. So equations where things that are soluble and ionic are going to be written as ions. Polyatomic ions are going to stay together, but the cation and the anion will be separated from each other if they are soluble and they are ionic. If they don't meet either one of those criteria, we're not going to be breaking them up into ions. We would keep them together. So things that are molecular, like say carbon dioxide, it would not get broken up. Also, if it's not soluble, so let's say we had a solid in there, it would also not get broken up. But if it is soluble and it's ionic, we are going to be breaking them up and writing them as ions. So go ahead and pause the video, write the reaction for this reactant right here, write the chemical reaction for that one. Hopefully what you got was sodium chloride reacting with lead to nitrate, double displacement reaction. We'd end up with sodium nitrate and lead to chloride. Now for these states, you'd want to be pulling out your nearest and dearest solubility chart, looking up the ions and deciding, is this thing here going to be aqueous or solid? So look up sodium chloride, look up lead nitrate, look up sodium nitrate, and look up lead chloride. And what you'll see is that sodium chloride, lead nitrate, sodium nitrate are all aqueous, but lead 2 chloride is solid. So the things that are soluble and ionic are the first 3 species in our reaction here, the 2 reactants and one of the products. But lead 2 chloride is solid, so it does not meet this criteria. It will not get broken up. So for our total ionic equation, what we're going to do is we're going to break up the things that are soluble and ionic. Sodium chloride will be written as separate sodiums and separate chlorides. We know there's 2 sodium ions. We're going to show their charge because we're actually saying that we know that they are positively charged sodium ions, and there are also 2 negatively charged chloride ions. So we're going to write those out. Instead of writing it like this, we're going to write it like it actually is. It takes up a lot of space. We know also, for example, our lead 2 nitrate, it's not that the lead 2 is actually associated with the nitrates, because it's an ionic aqueous substance. So we know that the lead is separated and the nitrates are separated. We have 1 lead for every 2 nitrates, and they are no longer associated with each other, floating around in the water. So what we'd end up with is an equation that looks like this. We still have the sodium chloride, but we know the sodium and the chloride are separated. That's what it means to be an aqueous ionic substance. We know we have lead nitrate, 1 lead and 2 nitrates, but they're also separated. We know that, so we're writing them as that. The sodium nitrate, same thing. It's a ionic aqueous soluble ionic substance, so the 2 sodiums are separated from the 2 nitrates, but the lead 2 chloride is not aqueous. It is ionic, but it's not aqueous, so it does not get broken up into its ions because it is solid. Anything that gets broken up must be soluble and ionic. This here is our total ionic equation. Not hugely useful, but it is the first part of what we're doing when we get to our net ionic equation. So to write a net ionic equation, essentially we're doing the same steps, we're just cleaning it up at the end. So you're going to write out all your soluble ionic compounds as ions, make sure they're balanced, and again, you probably want to start with a balanced chemical equation, and then look for things that are soluble using your solubility table. Make sure if they are soluble and they are ionic, you're going to write them as ions, keeping them balanced. Anything else, keep it in the formula, but you're going to make sure that you keep them together. So for example, if you look up lead 2 chloride, we see that it's solid, so we're not breaking up into its ions. So this point we have what's called the Total Ionic Equation. To go from the Total Ionic Equation to the Net Ionic Equation, we essentially just have to clean up the equation. So if you look at the equation there, you look at the Total Ionic Equation, you realize they're like terms on both sides. These we call spectator ions. They're not doing anything. They're there at the beginning, they're there at the end, unchanged. So because they're not doing anything, we can ignore them. We're going to cancel them out, get rid of them for both sides, and then just clean up the equation, rewrite it without those spectator ions in it. So if we go back to our reaction, we write our Total Ionic Equation, and then we look at it and say, okay, we got all our ions here, we got everything here, but we've got 2 sodiums over here, and we've got 2 sodiums here. So if you start with 2 sodiums, and you end with 2 sodium ions, they haven't done anything, so let's just ignore them. They're there, we just don't care about them because they're not doing anything. The other thing is the nitrates. We've got 2 nitrates here, we've got 2 nitrates there. So obviously if we start off with these 2 nitrate ions and you end with the same 2 nitrate ions, they haven't done much. But what has done something is that these lead ions here started out as aqueous. These 2 chloride ions here also started out as aqueous. And when they went through the reaction, they became a solid ionic crystal. So if we take that Total Ionic Equation, cancel out the spectators, and rewrite it, and again, we put the lead first just so we have the cations first, we would have our lead plus our 2 chlorides forms lead 2 chloride. That is our Net Ionic Equation.